welcome. This is my uh, beginner's breakdown and analysis of one of OpenCog's articles on using Minecraft to benchmark or test artificial general intelligence. Yeah, so before I start, I just want to say like this is my first video, and I'm starting to post these videos because I want to build my competency in artificial general intelligence, and giving myself these kinds of like assignments uh, really makes me feel like it gives me measurable progress goals, and it gives me deadlines too. So hopefully by the end of this journey, I'll be uh, at like a graduate level in terms of artificial general intelligence. So yeah, uh, let's get started. This preface is kind of just like background examples of artificial general intelligence. I'm assuming you already know what artificial general intelligence is, just because you're here on this channel. But yeah, so in this first paragraph, um, Alexei, he he makes the argument that um, the current tasks that we use to measure progress in AGI are either too narrow or they're too domain specific. Even if if they're a general task, it's still too domain specific. So for example, um, later in the article, they'll talk about StarCraft, and basically they really tailored that AI model to only be able to play StarCraft and do nothing else. And that was just what they might not have and that was just because that was what it was incentivized. They weren't incentivized to make a model to be able to play any game, but they were incentivized to make a model to play just StarCraft really well. Um, so and then here's an example from him. Um, these modern NLU or language understanding models, like Ernie and T5, they do really well with um, understanding human language, but they can't do anything else. And and I think he's being a little too hard on uh, I believe Ernie's by Baidu, the Chinese company, and T5 is by Google. I think he's being too hard on them, just because uh, they are obviously not AGI, but they're more general than what existed like 10 to 15 years ago. Um, so I think our field, the AI field, is moving towards more general solutions. And it's not fair to say that those solutions will not contribute to the eventual invention of AGI. Um, and then yeah, and by the way, I'll probably do another video on Ernie and T5 uh, about transformers, because that's what both of them use uh, to get their amazing results. So, anyways, um, yes. So now he's talking about physical versus like virtual world testing, and he makes the argument that if we were to test AGI in the physical world, we would have to uh, focus on a lot of the things that allow humans to uh, interface with the physical world, while in a virtual world you don't have to worry about that. You can worry mainly on the important parts of AGI, such as like the higher level cognitive capabilities like strategic planning, understanding, things like that. um, I would agree, although I would say that in the physical world there's a lot more possibilities. uh, so like you're not the AGI isn't locked down to like maybe 100 actions, or if that's generous, but like maybe 10 to 15 actions to achieve something, versus in the physical world where they would have like maybe 300 to 500 possible actions to achieve something. Basically, what I'm saying is if the AGI is being tested in the physical world, it has the potential to be much more creative versus the virtual world where everything is more constricted. Um, anyways, yeah, so you might not know what end to end learning is. Um, so uh, there's end to end learning, and then there's another category called uh, recurrent neural network. It's like sequential learning, I guess. And basically, end to end learning is when the neural network um, it does all its learning in like one go, versus with sequential, where it's like it takes a lot of passes through the neural network, uh, like over time, I guess, to teach the neural network. So, for example, uh, like with transformers, for example, like Ernie and T5, they use end to end learning, and that's because they take the whole sentence and then they process it, versus uh, a recurrent neural network, which will go through each word in that sentence, um, and then like modify itself from there. And Transformers still do like that word to word thing, but they look at the sentence as a whole, uh, like while they're going through each word. I don't know if that makes sense. I'll get more into that with the Transformers video, I guess. And then yeah, you might not know what reinforcement learning is, and that's basically like coming from a behaviorist point of view. So what was his name? Skinner. Like basically like you just give the AI like rewards for achieving like specific goals within a domain, and then you just hope it does enough tries and enough like playthroughs that it figures out like the proper behaviors that will lead it towards getting the most rewards. Um, yep, and then the deep part just means like there's a lot of layers. Um, yeah, so Google made like this uh, agent that could play a lot of Atari games without being told any of the rules. It just figured all those uh, it figured out what to do just by getting knowing that it got a reward by like at the end. So like let's say it's playing Pong, like it didn't know the rules of Pong, but it just knew that like if it gets like eventually it found out uh, that like it found out the rules implicitly versus being told exactly like make sure to move the ring this way, or not the ring, the block this way, so that the ball doesn't go in your side. um So yeah, and then the article makes the argument that like this kind of reinforcement learning is really just like reflex behavior. So like it doesn't know what it's doing. It doesn't understand anything. It's just it's like a bunch of if thens that it's constructing within its mind. Like if then statements, like if ball is here, then move this here. Um, so it's not really thinking too hard. It's just thinking very linearly. Um, and then they go to the example of Alpha Star playing StarCraft. So like that was a uh, model that beat like pro players in StarCraft, which was a big achievement. But it's saying that um, it, basically it's saying that reinforcement learning required a huge amount of like uh, tailoring towards specifically StarCraft to get it to the level it was at. So like even though Alpha Star did have to do a lot of strategic planning, a lot of supervision was required. And ideally within artificial general intelligence, like uh, it can think about these strategies by itself. Like you just tell it the rules of the game, like what you would tell a human to play StarCraft, and then it'll just go and figure things out. And my take on this opinion, where he's like discounting reinforcement learning, is that um, I think that StarCraft, like, I feel like if you look beneath the surface of this Alpha Star, you'll get some insights as to how to get an AGI to learn to think strategically, and then just like analogize the StarCraft world to like more general, uh, more general games or like situations. Okay, yeah. So this is a interesting paragraph. There is another competition called Basalt, and they have these kind of looser goals. Um, and but the article is saying that they're just learning. It's just like what I was saying above, like they're just learning sequences of actions, without understanding like what those actions actually do. So like if put in a different situation, they wouldn't know what to do because they don't understand how the world works, and they since it's not following the set of actions that they know already, they won't be able to work in that new situation. Um, and yeah, that's very understandable. But then I think this like I want to flesh out what I believe the word understand means in the field of AGI. Like this is just my intuition. Um, Understanding is like for an AGI that is just knowing uh what actions from what states lead to what other states. So like if I have a pencil and I write on a piece of paper, now the paper has some writing on it. Um, and then like breaking, but that, like, like that concept of like knowing what actions do what, and like knowing what causes what, basically, breaking that down into like the fundamental level. Like for us humans, like I know that the pencil uh, makes that mark on the paper because of like friction and like how my muscles move. I know how those work. I know like uh, why like the lead is that color. Like just knowing, like it's like knowing like the agent just has to know what causes what. And I believe that these reinforcement learning agents, they do implicitly find out what causes what. Um, so in those like specific circumstances that they are trained in, they understand them. Um, but I guess the problem is, are they able to extrapolate their understanding to other situations with the same elements but a different task, or like one unknown? So they're saying that the uh, what the reinforcement learning agents are doing is kind of similar to what the Atari game agent was doing, where it was just doing basic if then statements. And I'd argue that like the real world is just a lot of if then statements. And you form those if then statements with your understanding, which I just spoke about. Um, so now they're just like kind of praising Minecraft's like richness. Um, yeah, there's not much here. So now they're gonna talk about what challenges they propose that would lead towards AGI. And to them, that is much more open-ended goals than what was explained above. Like instead of just get find diamond, they're just saying find new materials and find new items and get new items. Um, yeah, and I think that that works better than having those specific goals. Yeah, so they're saying like, okay, open-ended goals are good, right? But we still need our agent to like actually be able to achieve like specific goals like the reinforcement learning agents could. Um, and now they're just kind of like talking about like uh I don't know why they're talking about it honestly. Yeah, okay. That's it about Minecraft, honestly. I hope you guys understood what the article is saying. And then I can tell you about like all these things I highlighted really quickly, so you don't have to look them up yourselves. But Singularity Net is like, uh, it's well the founder of OpenCog, who's Ben Gortzel. He made Singularity Net, and it's basically like it's a they're selling like AI services on the blockchain. So like if you want an AI to analyze like your data or like do a task, you can go to SingularityNet, pay them in their coin. I think it's like AGIX or something, and then uh, it's like software as a service, but like through the blockchain, and it's decentralized, and it's using AGI or AI. And their vision is like if you combine all these AI services together, you will get something resembling AGI, where it's just like it can do so like Singularity Net can do so many things that it's like an AGI. I don't know. Especially if you combine them together, which is what they're saying here, AI services language. Um, if you combine these services in a good way, you'll get to an AGI. And by AI services language, I think they mean like like with Python, there's like the Python libraries like matplotlib that lets you plot, make graphs, or like SciPy that lets you do scientific operations easily, or like all the other ones that like just make life easier for you. Um, SingularityNet would be like, or the AI servicing language that comes with SingularityNet would be like the Python that lets you use, instead of Python libraries, it would be like AI services. And then True AGI is, uh, it's like, I looked it up on Reddit. It's like a marketing arm for SingularityNet. So like they help corporations and people hook up with SingularityNet and use the services on SingularityNet without having too much technical knowledge. And then OpenCog Hyperon, that's like the new version of OpenCog. Like they're redoing it. OpenCog was like founded in 2008, and I guess they like thought some of the ideas were a little uh, old now, and because there's been so many improvements to the field. So, but yeah, OpenCog, if um, OpenCog, like it was an interesting idea. It's like there's an atom space, which is their name for like a huge like giant knowledge graph, um, that like individual AI would like use and like modify and update, uh, like all at the same time, like concurrently is the computer science way to say it, like simultaneously. Um, they would like use this knowledge graph and cooperate, and all these like little AIs that use the same knowledge graph would coalesce into an AGI just because they had so many functions. So yeah, that's the article. I'm glad I finally got through it. Pretty rough uh, first video, but it feels good to actually understand shit now. Look forward towards that Transformer video that I'm gonna do probably next week or something like that. And I'll keep building in public. Peace.